Another day, another Betso product to repair. Welcome back to Circuit Fix, and today on the bench I have a wireless Betso timecode box. The model number is S-Box 2RF. Now these are used on film and television productions to sync up the audio with the video in post-production. This generates a longitudinal timecode stream that gets fed into the camera, which the camera then writes to metadata on the digital file that gets sent to post-production. There in post-production it gets married up with the digital audio file that also has timecode metadata. Now the customer states that this unit will not power on, so let's crack this thing open and see what's going on with it. Now I've never opened one of these up before, but I suspect there are some screws underneath this label. So I'll introduce a little bit of hot air, maybe around 200°C. Let's see if we can loosen this up. Maybe I can lift this corner and get this under it. Alright, I was correct. Underneath this label are two torque screws. I'm going to need to continue to clean this glue out of the holes here. Alright, these are T10s. Alright, we have our screws removed. Perhaps this will just lift off. Okay, now we have it. And it's tightly packed inside this container here. Alright, these connectors are being held on by set screws, and this one's being held on by a nut. So I'm going to remove those to try to get the board out and have a closer look. Let's remove the antenna nut, the SMA connector. And I need to release these two set screws. It looks like the RF board is separate and can be removed first. I'll remove this ZIF connector. And remove this screw. It looks like our RF board may just pick straight up out of here. And that's removed. Now that I have the RF board out of the way, I can see where the contacts meet the board for the power coming from the battery and the ground. So I'm just going to pop a battery in real quickly and just make sure the voltage is getting to that point on the board. I brought the Circuit Fix Fast Reader app up on the screen so you can see the meter readings, and now I'll check the board for battery voltage. And we have 1.4 volts. So the board is getting power. So it's not going to be something easy. If I can take these other two screws out, maybe I can get the board out. So I'll bring the battery connector up so it can come with the board. Looks like the LEMO is connected on this zip socket, so I'll take this off as well to avoid damaging that. I'll have to desolder the BNC connection from the board. And now that's removed. I think the board will fall out now. I'm just going to desolder the ground wire from the case to the board for now, just to get the case out of the way, and we'll put it back later. Alright, let's begin our visual inspection. It shouldn't take long at all. This is a very tiny board, and I don't see anything that should cause a failure on this side of the board. Now we see a STM32 microcontroller, so that means this thing has got to generate a 3.3 volt rail and maybe some other voltage rails to operate that. And we have a 1.5 volt battery as power, so there's got to be a boost converter in here somewhere, and that could be where our problem is. I see two coils for different voltage rails. There's one and here's another. So let's put the meter on here. We should look for, yeah, that's our 3 volt rail, that's present. Over here, 1.4, that's our battery voltage. So looks like this guy's working. I wonder if that pin, yeah, that's the output pin on the boost converter. What to check next? And I just flipped over this ribbon cable. It looks very custom made for this product, and it's got a burned trace on it that's obviously a problem. I'll contact the manufacturer and see if I can get a replacement. But for now, this repair is on hold, and we'll update you with a future video. Thanks for watching. Circuit fixed.